Welcome back to our lesson practice review, where we are going to go through Chapter 2, Lesson 4 today to kind of summarize what happened in actual lesson for Lesson 4. Is it went through two main things. The first one is hopefully review about completing the square, probably something that we talked about in Algebra 1, but it's a way to rewrite a parabola or a quadratic in vertex form. And really, it's usually used to help us find a vertex so that we can graph it. So, for example, in this one here, what we can see here is that we have x squared minus 8x plus 9. The way we do this is we're going to kind of separate the terms with x in it, and we're going to add something new into those parentheses. Whatever we add into those parentheses, we also have to subtract it somewhere else in the equation, because we want to keep the equation equivalent to what we started with. We're not trying to just like add a number, because that changes things. If we add it and then subtract it away somewhere else, then that kind of keeps it the same. It's like adding 0, it doesn't do anything. So the nice part about this number in the box here is it's always half of this number squared. So in this case, half of negative 8 is negative 4. And if I square that, I get positive 16. Whatever goes in that first box is also going to go in that second box, which is 16. Again, because I'm adding 16, I'm also going to be subtracting it somewhere else. Then what I do here is I get this, which is one of our identities we've talked about, where when we factor this, it becomes x minus 4 times x minus 4, which helps us put it into vertex form. Then the outside piece, our new like k value here, the thing that's added or subtracted on the outside, is just whatever this is. So 9 minus 16, which is negative 7. So it tells us the vertex is at 4, negative 7. For the other part, we talked about circles. Same idea, still completing the square here, right? The first one is already kind of in our circle formatting, whereas this part here needs to be added something to it. So half of negative 4 is negative 2. Negative 2 squared is 4. Anything that we add to the inside, we also have to subtract to the outside. Then when we factor this, it's one of our identities, so it becomes y minus 2 squared. And I'm going to add this 4 to the other side so that it's in our circle format. So the radius of the circle is 3, because it's the square root of that. And then the center of the circle is just the opposites of this. So negative 5 and positive 2. Okay, let's get into the actual practice part. So problems 1 and 2, circle whether each equation represents a parabola or a circle. It's pretty straightforward on how to do these, because the only difference between a parabola and a circle in the equation is that you're going to have both x and y being squared. So in this one here, only the x is squared, and so we know that that one has to be just a parabola. Whereas this one here, for number 2, we see that the x is squared in the equation and also the y is squared in the equation. Sometimes we may have to put it in standard form to see that, but we know that this one is going to be a circle. For problems 3 and 4, change one term of each equation so that it represents a, and then for number 3, we're doing a parabola. So right now, because these are both squared, I don't want that. And so all I'm going to do is I'm going to take this y squared and I'm going to change that term into just y. And again, just recognize that this is telling us to change a term. This is not equivalent by any means. We're definitely changing what these equations mean. So now this would be a parabola. Whereas this one here, we want it to be a circle. So the only thing that I would change here is that in this term here, I already have the x's being squared, but I also want the y's to be squared. So I'm just going to put a little 2. And that would make it a circle, because now the y value, when I expand that, becomes y squared. For number 5, select all equations that represent a circle. Again, I'm just looking for anything that has both terms being squared. The b is not one because y is squared, but x is not. Both of these ones are squared, so I'd say c. When I expand this, it doesn't look like it's squared now, but if I do y minus 3 times y minus 3, that first term, y times y, becomes y squared. So that would also end up being a circle. Whereas this last one, only the x values are squared. And so our answers that would be circles are just A, C, and D. Number 6, rewrite the equation y equals negative 2x squared plus 12x minus 10 in vertex form. So they definitely threw in a tricky one here. The first thing that we have to do to put this into vertex form is we see that each of these terms is divisible by 2, and I see that there's a negative in the front. So I'm actually going to factor out greatest common factor, that negative 2, out into the front. So y equals negative 2, and that was inside the parentheses, x squared minus 6x plus 5. And now I'm going to pause this equation here, and I'm really just want to focus on making this part into vertex form. And then when I'm done with that, I will distribute that negative 2 back into the equation. So right now I have x squared, minus 6x plus 5. So to complete the square, x squared minus 6x plus something plus 5 minus something. I'm running out of room here, sorry. Divide this by 2, which is negative 3. Negative 3 squared is just 9. And then I subtract 9 over here. So what this ends up becoming is x squared. Yeah, well, that's fine. X squared minus 6x plus 9 in parentheses minus 4. And now this is one of our identities, and that ends up becoming x minus 3 squared. It's also, the reason I keep writing this like little negative 3 here is that ends up what we get for inside of our parentheses as well. So again, you can go through and just factor it if you really want to, or you can know your identity, but it ends up becoming x minus 3 squared, and then back to our green, minus 4 here. So I officially took this part here and I completed the square to put it into vertex form. The issue is that I need to go back to my red equation over here and place this inside the parentheses here. So now we are at the point where it's y equals negative 2 times, and then another set of parentheses. This is why I said it's tricky. I don't know why they made this one so challenging to kind of start us off with this type of equation. And so when I do this, now what I'm going to do is distribute this negative 2 into both of these terms. And so my final vertex form here would be y equals negative 2 x minus 3 squared plus 8. So a lot of steps in that one. We might need to get a little bit more practice on questions like that to make sure that we feel comfortable with it. I probably could have formatted it a little bit better too, but I'm sure we'll see problems like this in some of our spiral review. Problem 7 and 8, determine the key features of the graph of each equation. So in this case here, it's a parabola, so we're looking for the vertex. So I'm just taking this right here, let's do it in purple here, and I am going to put it in vertex form using what we know about completing the square. So x squared plus 4x plus something minus 11, minus something. And so when I do this, I'm going to divide this by 2, which becomes 2. 2 squared is 4 and goes in both of those boxes, which means that this becomes x plus 2 squared. Negative 11 minus 4 is negative 15. And so this is my new equation in vertex form. So I know that my vertex is going to be at negative 2, negative 15. Let's make sure that we recognize this our answer up here. And then for B, for 8, we are trying to find the center of the circle and then what is the radius. And so in this one here, the only part I need to do is I need to kind of complete the square for my y's. So x minus 5 squared stays the same, plus y squared plus 12y plus something minus something equals 13. Half of 12 is 6. 6 squared is 36. And now I'm going to make that x minus 5 squared. This becomes y plus 6 squared minus 36 equals 13. If I add this 36 to both sides, my final equation, x minus 5 squared plus y plus 6 squared equals 49. And so I know that my center is at 5, -6. And my radius is at 7 because that's the square root of 49. Problems 9 and 10. Fill in the blanks to write the equation of a circle with the given center and radius. So for number 9, we know that we want the center to be 3, -4. The 3 part is already done. The next part that we need to do is we need to find something that gives us y plus 4 squared. So we're looking for what are we going to be able to add into this part here that would be y plus 4 squared, which in this case would be, what is that going to be, 16? No, 8 here. The reason that we get 8 on this is because if we were to divide that by 2, that would be 4. And that's really like where this number is coming from. So if we were to do 8 right there, then what we would end up getting is, oh man, not a lot of room in here, x minus 3 squared plus y squared plus 8y plus half of that, which is 4, squared is 16, minus 16 equals 20. This part here becomes y plus 4 squared, which is what we wanted. And then if we add the 16 over to the right side, we get 36, which gives us square root of 36 is a radius of 6. So all that to tell us that this number in front of y has to be 8. I feel like 10 is now going to be tricky after I've tried this one. So, okay, first of all, center's got to be 2, 3. Radius has to be 2. So in this one here, we have x squared minus something x plus something plus y squared minus something y plus something. So we know that if the center is 2, 3, then I have to have x minus 2 squared and y minus 3 squared. So to do that, I know that this has to be 6, and this has to be, was that 4? Yeah. Which means now, so I'm going to take these boxes away because I know what those numbers have to be. What means I have these numbers here, which when I add them in, I have to subtract them on the outside. So whatever this is, half of 4 is 2, 2 squared is 4. It's supposed to be 3, 6. And then 3 squared is 9. So I also have to subtract 4. I have to subtract 9. And so in the end, what I end up getting here, this whole thing becomes x minus 2 squared, which is what we want. This whole thing becomes y minus 3 squared, and then minus 13 equals, whatever. And so I'm going to add the 13. No, I lied to you. That needs to be equal to, this, I guess the radius is going to be 2. So this has to be 4 on the right here. So add 13. And so this has to be, what is that, -9? Is that right? Yeah. Oh man, that's a tricky one. So this, then our final, like what we're plugging in here, this has to be 4. This has to be, actually, let's do this in the right colors here. This has to be 4. We got that from here. This has to be 6. We got that from here. And then this one in green here. Oops, this one's 6. Sorry. And this one has to be -9 because we want the outside to be 4, which gives us the radius of 2. Whew, that's a messy one. Sorry if I threw more confusion in there than actually explanation, but we got through it. Again, if you have questions on that one, maybe just ask me that one in class. That was not the best explanation on that, my bad. All right, let's wrap up with our spiral review here. We got problems 11 and 12. We got x minus 2 squared minus 4. We're asked to draw the graph. So when we're drawing a parabola, we'll probably get more practice on this in class. I feel like, we jumped in here expecting you to kind of know how to graph this, and we may not know how to do it just yet. I usually like 5 points when I'm graphing a parabola, and we start with our vertex, which in this case here is going to be 2, -4, and I kind of put that one in the middle because with a parabola, the shape that we're looking for, since this one is positive, is something that looks kind of like this. Oops. And we should get, kind of 2 points on either side is the goal here. The nice part is that they are, you know, um, both of these are symmetrical around that axis of symmetry there. So if I find the right side, it's pretty easy to find the left side. So to start, 2, -4. I'm going to plot that point on our graph over here. 2, -4. That's my first point, which is my vertex. Now, from here with parabolas, we don't have to deal with fractions too often, especially if the equation we're given isn't fractions. So I usually just like to go up by ones, right? What's the two numbers right next to 2? Well, that's 3 and 4. So how do I do that? Well, now I just have to plug that into the equation. So we're doing f of 3, which is 3 minus 2 squared minus 4, which becomes 1 squared minus 4, which becomes -3. So that's my next point here, 3, -3. And then when I plug in 4, I guess I should do it a different color here to be nice and pretty. And we do f of 4 is equal to 4 minus 2 squared. 4 minus 2 is 2. 2 squared is 4. F of 4 is just equal to 0. So when I go up to graph this for 0, and so here's the deal is I'm going to call it good for the right side there, and we'll go ahead and do this in black to kind of see that our parabola, this is 1/2 of our parabola here. The other half is going to be just on the other side of it. And again, just due to time, I'm not going to go through this, but really what we would be doing here is we would be plugging in, 1 to the left and 2 to the left. But what we would end up getting is I said that it was symmetrical. So it becomes, these are going to be the same and these are going to be the same. So what we end up getting is 1, -3 here and 0, 0 right here, which then when we kind of copy that on the other side, we get our parabola shape. And there's that sketch of my graph. So I got 5 points by plugging in the points around the vertex pretty much. For number 12, identify the x-intercepts. Well, we kind of already have those given to us from our table here from our sketch. X-intercepts are when the y value is 0, which is our top and bottom point here. So our first x-intercept would be 0, 0. And our second one would be 4, 0. And that wraps up our lesson 4 from chapter 2 practice. We got a lot on quadratics, a lot of kind of challenging questions on this one. So definitely if you have questions, make sure to let me know. I'm happy to re-explain certain questions or maybe go through them a second time.